NIT Raipur, and 4th International Conference on Machine Intelligence and Signal Processing, MISP. I welcome all the respected session chairs and participants. Before we start the session 20, let me introduce our esteemed session chairs. Just wait. So our first session chair is Dr. Deepak Ranjan Nayak. Sir, so Dr. Deepak Ranjan Nayak is an assistant professor at Department of Computer Science and Engineering, Malvi National Institute of Technology, Jaipur, India. Prior to this position, he was an assistant professor at the Department of Computer Science, SV National Institute of Technology, Surat, India. Done his postdoctoral fellow at Indian Institute of Information Technology, Design and Manufacturing, Kanchipuram, Chennai. He received his PhD degree in Computer Science and Engineering from National Institute of Technology, Rourkela, India. He has published over 50 articles in peer-reviewed journals and conferences of international repute. His current research interests include medical image analysis and classification, machine learning, deep learning, pattern recognition, and computer vision. His publications have more than 1150 citation, H index of 19 and I index of 27. One of his papers was included in ESI highly cited paper. He has received 2020 CMES Young Research Award from Tech Science Press for outstanding research in computer modeling and simulation. He has received international travel grant support from Department of Science and Technology, DST, Government of India in 2017. He has also received the Outstanding Reviewer Award by Computers and Electrical Engineering Journal elsewhere for the year 2017. He is currently implementing one research project funded by DST, Government of India in the field of medical image analysis. He serves as reviewer of more than 60 peer-reviewed journals. He has also served as technical program co-chair and committee member of several conferences of international repute. He is member of IEEE. He serves as an editorial board member of International Journal of Medical Imaging and Technology, and a guest editor of Mathematical Bioscience and Engineering Journal. So welcome, sir. Welcome, Deepak, sir.
Yeah, thank you so much. Thank you so much for the kind introduction.
Yeah. So our next session chair, Dr. Sonali Agrawal, ma'am. So Dr. Sonali Agrawal is presently working as an associate professor in the Information Technology Department of the Indian Institute of Information Technology, IIIT Allahabad, India. She has received her PhD degree at IIIT Allahabad and joined as faculty at IIIT Allahabad, where she is teaching since October 2009. Dr. Sonali Agrawal main research interests are in the same in the areas of stream analytics, big data, stream data mining, complex event processing system, support vector machines, and software engineering. Welcome, ma'am. Welcome, Sonali, ma'am.
Thank you.
Our next session chair, Dr. Sanjeev Sharma, sir. Dr. Sanjeev Sharma is working as an assistant professor in CSE department in India, in Indian Institute of Information Technology, Pune. He has received his PhD in Information Technology and MTech in CSE from Indian Institute of Information Technology and Management, Gwalior, MP. He has published several articles in international journals and conferences, including SCI journals. He has also served as reviewer of papers, articles of many reputed international journals and conferences. His area of research is soft computing, robotics, biometrics, and nature-inspired algorithm and deep learning. Welcome, sir. Welcome, Sanjeev, sir.
Thank you for a nice introduction.
Yeah. So in this session, we have 5 papers to be presented. May I request to session chair to start the session? May I start session?
Yeah, we can start
Yes,
the
yes.
session
Yes,
now.
yes. So as for now, I invite our first presenter, paper ID 152. Paper ID 152.
Yes, yes, sir. I'm
Mr.
present.
S. Naga Malik Raj.
Yes, sir. I'm
Just,
present.
yeah, just wait. Just I'm making you. Yes, Malik.
sir.
Now you can share your screen and start with your presentation.
Yes, sir. Yes, sir. So, good evening, everyone. So, my name is Malik Raj. I'm Malik Raj. My paper ID is 152. So, my paper title is Multitask Deep Learning Model for Diagnosis and Prognosis of COVID-19 using threshold-based segmentation with unit and segment classifiers. So here, I have used a unit and segment classifier on ML COVID-19 CT scan images. So these are the table of contents agenda. First one is background and literature survey, problem description, methodology, results and discussions, conclusions and references. So the main challenges of the segmentation work are lack of data and annotated data. Coming to medical image analysis, if we want to do any segmentation, the first disadvantage is we don't have any sufficient data, and second one is annotated data. Since all the benchmark data are available in a Luna 16 dataset or in a LIDC IDR or in a Kaggle data repositories, but all those are the benchmark dataset. But if you want to work on a real-time data, all those data are not an annotated data. In order to annotate the data, we need an annotation from at least 3 to 4 radiologists for annotations. That is one of the main challenges, and second one is a lack of data. So instead of expensive models like ResNet 50 and DenseNet, we have developed a multitasking approach to reduce overfitting and improve the results. So facing by observing these three important challenges, we propose to train our neural network with the three tasks, that is reconstruction and segmentation, in order to both classify and segment the lesion regions. So these are the background of our research work. So this is a literature survey. So author one has proposed a model that is in a dilated multi-residue block network based on UNet. So the outcome, the model has been improved the process while shortening the time it takes to segment the lung and blood vessels, trachea and other organs to determine whether large nodules had a higher cancer irritating. And the research gap is the position of the CT scan is not accurate. And the author number 2 has proposed an objective that is in a deep learning framework for lung CT scan segmentation. And the dice coefficient he achieved is 83.74. And the model the research gap here is the model failed to identify a similar image density, such as a result model performance was not up to the mark. If we observe the literature survey here, the other one and the other two, both the dice coefficients are very minimal. That is, the other one has an 85% and the other two has an 83.74%. So our research work is to improve the accuracy of the models, improve the dice coefficients of the model. So these are the two. These are the next important challenge we have to overcome while doing a segmentation and a medical image analysis. So coming to the problem descriptions. So in the problem description, the first one is we have to classify an image accurately. That is the first thing. So we have in the first step we have taken a CT sketch and CT scan image, and next we have enhanced the image, and after that we have differentiated the image into a blood vessels and a bone. We have differentiated it, and next one is we have marked the image, and next we have segmented the image, and we have defined the images. So in between this, we have enhanced, and next one is a gradient images also we have found it out. This is the flowchart of the proposed architecture we have done. And next one is region growing after refined segmentation is if you observe the histogram of an image, here in the particular region, in this particular region, the histogram has a peak. So there may be a chance of nodule here instead of an voxel positions. And coming to the next one is, this is a region-based segmentation. It has a 4 distinct stages. First one is an automatic selection. Next one is algorithmic stoppage. And next one is area growth. And the next one is a lung remediation. So these are the region-based segmentations we have done. And next one is a threshold segmentation. In the threshold segmentation, we have tried to differentiate between we have removed the unnecessary tissues like blood vessel tissues. We have removed the bones, and we have tried to concentrate on the nodules present in the CT scan image. And these are the various results of an signet and a unit model. And we have achieved right now we need to improve the results, and we have achieved a Dice quotient of 74 and 73%. We need to work it on these things. And these are the conclusions. To diagnose and make assumptions about medical imaging, it is necessary to conduct an analysis of the image segmentation included in this. So, and we have to find out a method to improvise the Dice coefficients of the CT scan images for the accurate finding out of a COVID-19 CT scan images, both more faster and an accurate model. In this study, 2 deep learning models, that is a signet and unit, both are the benchmark models and were used to detect diseased areas of the lungs of a COVID-19 patient. And these are the references. And thank you. And any queries, ma'am, and any improvements, please request improvements and suggestions from the reviewers.
Any query from the session chair?
Yes, I have one question.
Sir.
Are you shown any comparative study?
Sir, this is right now we haven't. I'm working on the comparative study, sir. Right now I working on a signet and unit. I need in future work I have to include that comparative study as well, sir. Right now I'm in the starting process of image segmentation.
But if you are not showing any comparative study, how we can consider you did good work or your work is better?
Sir, I'm successful in threshold segmentation and region-based segmentation, sir. So what I want to convey in this paper is, the main objective of this paper is, first of all, we have to differentiate between the voxels, because a group of pixels is nothing but a voxels that should be eliminated. And second one is we have to differentiate, we have to remove the unnecessary things like from a CT scan, that is a bone or a blood vessels that I have successfully achieved. After all, because of removing all this, I have achieved then a basic objective. If we next step is, second step, if I done this, if I give this images and input to a various classifiers, then we can then if we conduct a comparative study, then I most probably classifier or machine learning algorithm will give me good accuracy also.
And what is the source and size of your data set which you are taking in this problem?
Sir, right now I'm working on a Kaggle data set, sir. I have downloaded the data set from a Kaggle, and the size of the data set is around 10 GB, and the training and testing is 70 and 30, sir.
Okay, fine from my side.
Thank you, sir. Thanks for the suggestion.
Okay, I have one question. You have used 2 deep learning networks, Segnet and UNet. So, is there any specific things, because there are many other networks available? So, why you opted only these 2?
Ma'am, as per the literature survey and the meta-analysis, we came to conclusion. We drawn to conclusion that Segnet and UNet are the best in segmentation of biomedical images, ma'am. So through meta-analysis, we have drawn this conclusion, and we have worked on these 2 models.
Okay, fine.
Yeah, Naga, I have questions. First of all, what I could see is your model contains multiple stages, right?
Yes, sir.
But what people are concentrating, or researchers are concentrating now in this particular domain of research, is to design end-to-end learning model, right?
Right, sir. Yes, sir.
So why you have actually used so many stages? And I'm also concerned about your architecture, the proposed method. I could not find a single slide on the, I mean, the way you have used UNet and SegNet. UNet has several variants, more than 100 variants, even SegNet has.
Yes,
So
sir.
which architecture you have adapted for your problem?
Sir, I haven't integrated both SegNet and the unit, but I have conducted a separate experimentation, and from that I have drawn
That I
the
understand, but UNet, as I said, that UNet has several variants,
Yes, sir.
right?
Yes, sir.
So which architecture you have used for your problem, and also the subjective results. Subjective results means the visual results, because your problem is a segmentation problem, right?
Yes, sir.
So you could have shown us few outputs or few results, and you
Sir.
can also compare the results with the ground truths provided by the data set,
Yes.
right? Because these are the main major things in segmentation algorithm. So you just tell us why you are interested in designing such a methodology which is having multiple number of stages. What's the benefit you are getting from it?
Sir, since I am in the starting of the research progress and I am writing my, this is in starting stage, I'm working completely on the segmentation, basic things of the segmentation, sir. So that's why I have chosen the basic starting unit, which was proposed by others, and it's a basic SegNet process, and I have worked on it, sir. I have to concentrate more on this thing, sir, research.
Yeah, and also Sanjeev sir has rightly pointed out, if you will not compare your method with others, how can we say that your method is better than others? How can you compare with others, right? So we have to verify the effectiveness of your model.
Right, sir, right.
And one more point, what we could see is you have, I think, copied some paragraphs from the paper itself and put it on the slide, right?
Yes, sir. From my paper only, I had on this.
Yeah, which is not actually acceptable for PPT presentation. We all know that, right?
Yes, sir.
So it should contain some points which are important.
Yes,
This is a suggestion, right?
Yes, sir. Yes, sir. Thank you, sir.
Okay. Okay.
Thank you, sir.
Yeah. Thank you, Naga, for your presentation. Yeah. Please unshare your screen.
Yes, sir.
Yeah. So now I invite our second presenter, paper ID 276.
Yes, sir.
Dr. Mahua Pal. Yeah.
Sir, Mahua Pal, not Dr.
Yeah. Okay. Yeah, please, ma'am, share your slide
Yes,
and
sir.
start with your presentation.
Good afternoon, respected chairs, members, and audience present here. My name is Mahua Pal. Is my screen is visible, sir?
Yes.
Thank you, sir. So I am presenting a paper titled Explainable AI Model to Minimize AI Risk and Maximize Trust in Malignancy Detection of Pulmonary Nodules. I have arranged I have arranged my presentation under the following subcontents. It has been observed that AI technologies are steadily being applied to healthcare, and it can perform well at key healthcare tasks such as diagnosing diseases. The use of AI has the potential to assist healthcare providers in many aspects of patient care and administrative process. But most of these AI CAD models work like black box devices. Although the prediction accuracy of these models are quite high, but these models do not provide the reasons or fact explanation behind the model's predictions. So there is obvious a trust issue which needs to be overcome. Explainable AI is a set of tools and framework that helps to make a machine learning model interpretable, and that model could be deployed with confidence and trust. Building the trust while deploying AI model is the motivation of our research work. We worked here using lung cancer screening CT scan data. Lung cancer is by the leading cause of cancer death, making up almost 25% of all cancer deaths. So here we use 3 XAI tools for understanding the input features contribution on the prediction of the model. That is the explanation behind the model prediction. we use two popular post-hoc XI method. One is SHARP and another model agnostic tool. The name is LIME. The full form of SHARP is sharply additive explanation, and LIME is local interpretable model agnostic explanation. We used here XGBoost binary classification, which has also an inbuilt method to find out the contribution of input features in the prediction of the model. So we have used that anti-hoc XI method as well in our research work also. We did literature survey, and we found that significant amount of research work has not been performed on this XI-based CAD model on lung cancer domain. And from the literature survey, we also found that most of the past research work were conducted on post-operative biomarkers or on socio-economic status. But our model is developed to build trust in user mind, while model predicting the malignancy of pulmonary nodules to detect lung cancer from patients' CT scan based biomarkers. So this proposed model could help the healthcare industry to sort out which patient require immediate medical care without doctors' direct intervention at the starting phase. So our model is a novel approach to give a fast and trustworthy early solution with lung cancer interpretable prediction from patient's CT scan report. We used XGBoost classifier for supervised binary classification, and as I already mentioned, we used SHARP, LIME, and ELI5 XI tools for explaining the model prediction. We have collected here 1,307 data, which is publicly available for researchers under NIH, National Cancer Institute, DCBT site. Based on this prediction by XI tool, we then refined our model by rebuilding it by considering few important input features. And then showing the methodology, this block diagram showing our workflow. Here at first we collected the categorical data from XML files, and then we encoded into numerical. Then there was an imbalance in the data set. Benign data set was very less, and the malignant data set, the number of malignant data were more. So we oversample the data set using some oversampling technique like smooth, Addison, and Rose methods, and we compared the performance of the XGBoost classifier. Here we have used the XGBoost binary classifier as machine learning model. And we did the performance analysis by checking the performance metrics like the accuracy, then specificity, AUC under ROC curve, etc. And then we found that Addison performed better than other oversampling techniques. We also used the statistical approach K-fold method to get the better model output. And then after that, we applied the anti-hoc method of XGBoost classifier. There is a method ELI5 of XGBoost classifier, which we use to understand the contribution of the input features for behind the prediction of the model. Then we also next applied SHARP and LIME tools and got the visual heat maps as outputs. After observing the XI outputs, we selected few important input features and refined our model by rebuilding it, and the performance we found that it is higher than the previous one. So initially we had taken these 10 features, that is calcification, internal structure, lobulation, margin, subtlety, speculation, texture, number of nodules more than 3 millimeter, and malignancy. And then we also divided the data set 80-20%, 80% for training, 20% for testing, and we used the oversampling method, Addison. And Here, after comparison, we found that adenosine performed well, and we got the model means performance metrics, and we found the result was quite good. It was 92% accuracy, and then we applied the anti-hawk XCI tool ELI5, and here we found that behind the prediction, the features like calcification had a quite a good play with this weightage. So in the table it is visible. Similarly, then we used sharp post-op Excel tool, and this is also displaying the feature contribution. But here it is this particular plot is also depicting the positive influence and negative influence of the features. The red color signifies positive influence, and blue color signifies negative influence. Next, we also got some other output using SAP tool. This is a dependency plot by the SAP framework. Here, we have seen from this particular diagram, we can find out that if the nodule is the calcification of the nodule is popcorn type, and if its texture is like solid, mixed, or solid, then the SAP value will be higher. It means that that particular sample will fall under malignancy. Next is the force plot, which is used normally for local prediction. So force plot actually it is based on any single record. All the features values here led to the prediction value to minus 2.43, which was converted to benign plus. And here SAP plots only the important features here with their contribution. Next is this line output. Another XCI tool line also we applied, and it makes a surrogate model for a particular instance. This also gives a local prediction. So it creates a surrogate model for a particular instance and the vicinity of a particular instance. And here we found the value of calcification, lobulation, etc. That led to classify the sample as the benign class. Here, sir, at the beginning, we actually use this 10 features, input features, but after observing the output of this XCI tools, we only use the important features, and then we rebuild the model with the same classifier, exhibits classifier, and we found that accuracy is more. It is now 93%. Previously, it was 92%, and specificity is also higher. It is 88%. Previously, it was 86%. So in conclusion, I would like to say that our model successfully provided the fact explanation along with the prediction, and the model accuracy was good, and we could use this model for diagnosing other cancer diseases, and we had also future plan to explore other XCI tools, and also we would like to use this particular kind of model for multi-classification for grading the cancer diseases. So with this, I would like to conclude, and thank you for listening, sir.
Any query from the session chair?
Yes, I have a query.
Yes, ma'am.
Please go back to the last slide.
Yes, ma'am.
Last regarding
Conclusion.
conclusion.
Yes, ma'am.
So you see the last bullet point, you are saying that the proposed model provide trust in AI systems. Can you elaborate?
Sir, ma'am, actually, the AI model which can be used in for medical diagnosis and in other high-stake decision process, that model only predicts if it is doing binary classification, only the high risk, low risk, like that it predicts. But with XCI, these tools or framework, we also can. Here I have used where those XCI tools which actually gives the visual heat map. So with this, we can understand that which inputs input features are contributing for getting this prediction. And suppose, ma'am, if the input features selection is wrong, and then suppose the maybe the output is correct with high accuracy, but maybe by selecting the wrong features, the output is coming. So with the XCI approach, we can also understand not only the which features are input that we can understand, we can also understand that whether this is being correct or not. So it is making the model transparent. Beforehand, most of the AI model are the kind of black box and opaque kind, ma'am. So that we wanted to. Yes, ma'am.
Okay.
Yes,
Just about this concluding remark, the middle one,
Yes,
you
ma'am.
are showing that the execution speed of the new model is faster than the previous one. But I can see all your slides. You have not shown these evaluation parameters with the help of certain graphs or at one place. So you are showing the results in different slides. So it is very difficult to compare. I was just thinking how we
Yes,
can
ma'am.
compare, because each result is shown in a different slide. So I think this is my suggestion, like whenever
ma'am.
you are claiming some kind of comparison or conclusive remarks, so
Yes,
you
ma'am.
should mention that all these data at one place, maybe with the help of some table or graph, so that it can be easily visible.
Okay, ma'am. Yes, ma'am.
Okay, so
Next
that's
time
all.
I'll do that.
Yeah, that's all from my side. Over to others.
Yes, I have one question. Can you please move to a slide where you are showing complete feature and then you are selecting some feature? A slide is there. Yes, this.
Oh, okay, sir. Yes, sir.
No, you are selecting some feature from these feature in one.
Huh,
Yes,
sir.
fine. So how you are deciding these feature are good, or what is the criteria? Any rank you are deciding, or what method you are using?
Actually, sir, this is from seeing the this contribution, this weightage from ELI5 output, and then the sharp tool and line tool. Then we just found that some features are not so important, and then when we exclude those features, then the the model accuracy is getting better. So then I thought that it would be.
So you are using tool, okay?
Yes, sir.
Okay, and what step you are performing in pre-processing as you shown in your flow graph before apply to the data set? Before apply
Yes, sir.
data set to the algorithm, you are doing some pre-processing also, like oversampling. What method you are using for this?
Sir, actually, I ran addition also, then smooth also, and Ross method also, and then we 80-20% also we did with the classifier, and then we found that addition is performing better. Sir, I actually did not get the scope, so I just put only the 80-20% addition and smooth comparison here. So with this, in here we have selected this specificity because it's a medical data. So it's that 86% specificity value is given by Addison. So and then AC under ROC curve is also better. So that's why sir Addison was chosen.
Okay, all from my side. Over to other, please.
Okay, thank you, Moa ma'am, for your presentation.
Thank you, sir.
So now I invite our third presenter, paper ID 294, Miss Tarusi.
Okay. So good morning, one and all present here. So our research is on topic COVID-19 social distancing detection and email violation mechanism. So like these are the topics that I'm going to talk about today in this presentation. We will look into some background details. Then I have done some literature survey regarding the topic, regarding the research work that has been done in the field of social distancing. Then I will present our problem description, like what exactly the problem is that we are trying to solve in this research. Then I will present the methodology that we have followed to like solve this problem for social distancing. Then we will have some discussion on on results and the the results that we have got during this research. And finally I will conclude the things. So like now it's been like more than 2 years since the entire world is fighting with this COVID-19 virus. Like in these 2 years, almost all of us have spent a significant large amount of time being locked inside our homes. We are in 2022, but still many of us feel like it's 2020 only, because life is just like not moving. It got stuck. No theaters, no offices, no colleges or schools. But like now all of us have realized that the fact that we have to learn to live with this COVID-19 virus. And that is why in this research we have made an effort for the detection of social distance between like pedestrian, specifically for colleges, offices, malls, schools, and like other places like this. And for solving this purpose, we have utilized the advantages that we have today in the field of deep learning and computer vision. And obviously if we want to detect social distancing between people in public places, first of all we need to apply some object detection techniques. So like for this we have used the pre-trained YOLO version 3 and version 4 models. Now talking about some of the literature, like some of the work that has been done in this field yet. So the first paper named Monitoring COVID-19 Social Distancing with Person Detection and Tracking via Fine-Tuned YOLO V3 and Deep Sort Model. So in this, the authors have used a deep learning based framework for like automating this task of monitoring social distancing. They have used YOLO version 3 for object detection and deep sort approach to like track the identified people with the help of bounding boxes and assigned IDs. And from the experimental analysis, it is of the YOLO V3 and deep sort scheme did their best result with balanced FPS distancing in real life. They also use this in XSD in YOLO V3 where and like the limitation are like lower phase and it is
Tarushi,
like not suitable.
your voice
Yes.
is not clear. Hello, Tarushi, are you there? Hello, Tarushi, are you there? Yeah, please share your slide and continue with presentation. Yeah.
Some just facing some network issue here. Sir, is it fine now? Can you confirm?
Share your slide, Tarushi.
I have shared it, sir. Is it visible?
No, not visible.
I think you share again.
Okay, I'm sorry. Sir, can you confirm now? Is my slide visible?
No, not too visible to me. Ma'am, Sonali ma'am, it's visible
Yes.
to you?
No, it's not
No.
visible. She can try. Yeah, something is coming.
Tarushi has started screen sharing. Yeah, now
Yes,
it's
now
visible.
visible, I think.
Okay, thank you. So yeah, let's talk about the second research work, that is deep social distancing monitoring and risk assessment in COVID-19. So like the authors have proposed a deep neural network model with combination of adapted inverse perspective mapping, that is IPM technique, and SORT tracking algorithm, like the social distancing detection. They have also used this MS Microsoft Common Object, like this MS and like their model was able to perform a variety of challenges including occlusion, lighting variation shades, and partial visibility, and proved a major development in terms of accuracy and speed. Using deep neural network model, they have achieved an accuracy of sorry yeah, so like in third research, a deep learning based social distance monitoring framework for COVID-19. In this, the authors presented a framework using the YOLO V3 model.
My slide is
They
not
have also
visible at my end,
used
I think.
Yes, Tarushi, slide is not visible. Yeah.
Yes, now
No.
visible.
No.
okay. So, on top of the third research work, so they have used this YOLO V3 object detection algorithm. They have also used this transfer learning method, like to implement and to like increase the accuracy of the model. They have achieved 92% and 98% accuracy by the like model without and with transfer learning.
Hello, Tarushi. I think the problem from your side. So you just go to your result part and then the conclude this. Okay.
Okay, I'm sorry. I'm just facing a huge network issue today. Just try my best. Okay, so this
Yeah. Visible. Go to
covered in
go to result part and conclude this. Yeah.
okay, or should I skip this methodology part as well?
Yes. Continue.
Uh,
Tarushi, continue. Yeah.
okay, so should I skip this methodology part as well?
Yeah. Explain it. No problem.
Okay. So like what I wanted to say, that the entire project we divided it into 8 tasks. The first one was detection of objects. For this we have used YOLO version 3 and version 4 models. Like we know this YOLO models detect the objects that belong to 8 classes of this MS COCO dataset. So in task 2, our objective was to detect objects that belong to only people class. In task 3, we have done the perspective transformation. That is like after detection of the people in a video frame, what we are doing is that we are transforming the camera angle from the top view to the from the view to the top view. In task 4, we are getting the bird eye view, so we can in bird view we are representing every identify person with a dot, so that in task 5 we can like calculate the distance between the two dots using this Euclidean distance formula. Like in task C, we are just
Okay. Tarushri? Hello?
Yes, ma'am.
Okay, can you hear?
Yes, ma'am.
Yes.
Okay.
Okay,
Yes,
so
yes.
Yes, now visible, please. Quick.
yeah. Are you going to conclude?
Oh, okay. Okay, let me conclude this. I'm sorry.
Just show result
So
first and then
these are,
yes.
okay. These are the results. Like we have used some of the videos that like we have downloaded from YouTube. These are the results from YOLO V4 and V5. We have also applied like the number of count. We can see here like 12 people are violating the social criteria and 8 people are safe. This is a video of a mall. Just likewise, we have took video from different locations. This is a video from a city town center. This is a video. We are just I've just displayed the snapshots here of the video, and it is the result of this was the video from the college, and like this is the result of the video from the hospital that we have downloaded. So yeah, let me conclude this. So in this project work, we have proposed a deep learning methodology for the detection of social distancing between the pedestrians. With the help of computer vision technology, the like distance between people can be estimated, and like any pair of pedestrian violating the distance criteria are covered with the help of red boxes. And for validating this proposed methodology, we have used 4 different input videos, which was showing the walking pedestrians. And the visualization result showed that the proposed method is like capable of determining the social distance measure between people. And this model that we have proposed here in this research work can be implemented in any city, public transport stations, malls, school, colleges, and any other places like this. So yeah, this sums up our work.
Any query from the session chair?
Yeah, I have some observations. So Tarushi, first of all, thank you very much for sharing our paper. So I was surprised to see one of my paper there in your literature survey. So I'm asking the same question which I was struggling at the time of this experimental work. Like whatever videos we are taking, what will happen if the videos are having overlapping objects, means overlapping person. So like one is behind the other person. So have you identified such type of problems?
Yes, actually, like for that, we are using this perspective transformation. Like in compute OpenCV, like in Python OpenCV library, we have this function named WAV perspective. So what we are doing that using that, like we just try to like change the angle of the input video frame. Like from the front view, we are just converting it into top view, so we can actually we can actually observe that whether like we can actually identify that whether they are overlapping or not. I hope
Okay.
I'm able to explain that.
Okay, and the another observation is what is the motivation behind using this YOLO V3 and YOLO V4 for comparison? There
Actually,
are
you
other architectures are also available then.
yes, yes, I agree that there are many architecture also available, but like YOLO V3 and V4 are like widely used for this object detection purposes, and the base paper that we have followed was using this YOLO version 3. So we just tried to like solve the problem using YOLO V4, and we just tried to apply this email alert mechanism thing.
Okay, and my third observation is although it is good, like you have used this email based notification mechanism, but you can understand like we are observing these social distancing and all other preventive measures under real time scenario. So do you think some better mechanism can also be followed rather than giving an email alert? Because email may have means there is not necessarily it can be addressed in a real time fashion. So is there any
Yes.
other mechanism to be followed?
Yes, ma'am. Actually, the email alert mechanism was not like here. It is not meant for sending the individuals who are violating the social distancing criteria. Like, suppose there is an authority who owns, like there is some like admin who is like who is owning this hospital. So it is the email will be sent to his email box that in your area the social distancing things is not getting followed by the people. But yeah, there are more chance to improve this methodology. Like obviously this email thing is a bit slow. We need a faster, much faster system than this.
Okay, so that's all from my side. Thank you.
Thank you so much, ma'am.
Yes, I have one question. So suppose you are using YOLO method for the object detection. Okay. So, but suppose there is another object that is not a person. So your YOLO method will detect that object also. So how you can overcome that problem?
Yes. So we have like while doing this project, we have thought about it much. So yeah, what we are doing that in coding, like when YOLO models was detecting like every object, uh, we just gave an if else condition that if the detected object's id is equal to 80. 80 is like id of the objects, id of the people that are under MS Coco data set. So we just simply put an if else condition that if the detected object class id is equal to 80, then only we are processing it further, applying different conditions of like perspective transformation and others. Otherwise we are simply ignoring that object. So yeah, this is the technique we have like followed to overcome this problem.
Okay, so we already defined the object ID.
Exactly, like in MS Coco dataset, the people the people class id is 80. So we have already given that if else condition in the code.
Okay, fine. Okay, from my side. Thank you.
Thank you, sir. Thank you.
Yeah, hello Tarushi. It's of course a challenging task, right? So my question is, what are the strengths and weaknesses of your model? Strengths we could see. So what do you think that what are the weaknesses of your model?
Like sir, if the video is more complicated, like by complicated I mean like if the crowd is more,
More, right?
then
Yes.
like there are
Mhm.
so much chance to like in the beginning itself I have like defined that we have used the videos from the of the pedestrian walking in malls or hospitals and like schools and colleges. So
Yes.
comparatively the crowd there is very less if we like compare it with the crowd that exists in like public trains and transportation. So the weakness is this only, like if the crowd gets increased, then we might not get that much effective result than that we are getting in these places.
Then what do you think? How can we resolve those problems?
Sir, like for tracking, actually the thing is, we are like implemented this project, like we are pre-processing this video input frame by frame.
Yes.
Uh, we are just following the centroid tracking algorithm. Like there are many advanced tracking algorithm, sort, sort, and even advanced than sort is deep sort. So like if we try to apply those techniques, that maybe we can get much better result than what we have got today.
And what about your training data set size? From where you collected the
Sir,
training?
it's MS Coco dataset. We have used default, which is pre-trained on this MS Coco dataset. Like it contains around
Did you fine
more
tune?
than
Did you fine tune your model with any real time scenario data? That's what I'm asking actually. Did you fine tune your model on any real-time data? I think again she got disconnected, I think.
Yeah, yes, sir. I think
Okay,
it's
then.
disconnect. Yeah.
Yes. No,
Okay.
no problem. We can go ahead.
Okay. Thank you, Ms. Tarusi. You just unshare your screen. And now I invite our fourth presenter, paper ID 366, Mr. Swapnil Singh. Swapnil, are you there?
Yes, I am there.
Yeah. So now just share your slide and start with presentation. Tarusi, please unshare your screen. Yeah.
Is the screen visible?
No, not visible yet. Only coming as a message. Swapnil, reshare your screen, please.
Yes, I'm trying to do that.
Session, sir. Good evening. I am Surikant Singh.
Okay, yes. So you are
Mumbai.
from the other session, yeah?
Yeah.
Session 12.
Yeah.
So your paper ID 329, yes?
329.
So I think you present after the 421, paper number 420, means this session papers. Okay?
Okay. Okay. Thank you.
Okay. Yes, now visible.
Is it now in the full screen mode?
Yes. Continue.
Thank you, sir. Good evening, everyone. Today, I, Swapnil Singh from Mukesh Patel School of Technology, Management and Engineering, NMIMS University, would be presenting my paper titled COVCONNet, a deep CNN model for COVID-19 detection. This paper was written in collaboration with Professor Deepa Krishnan. The flow of the presentation is going to be background, followed by literature survey, next problem statements, methodology, results, and discussion, and at the end, conclusion and references. At the end of 2019, COVID-19 originated in the Wuhan district of the People's Republic of China. India reported its first case in January 2020, followed by which COVID-19 was declared a pandemic by WHO. Seeing the spike in cases, the government of India imposed a series of lockdowns to prevent people from panicking and to attempt to curb the spread of the virus. As symptoms began to rise in people, there was a need of diagnostic test amongst everyone, which led to the finding of RT-PCR, which is reverse transcription polymerase chain reaction. Though RT-PCR is the most used method to detect COVID-19, it has several issues. Meddling on the S threshold value, the time to get the results are the most common issues associated with RT-PCR. Hence, the search of another diagnostic test, which led us towards radiology, where we discovered that chest X-ray and CT scans can be used for COVID-19 detection. For this research paper, we reviewed 20 papers and concluded the following: random forest, k-nearest neighbors, and support vector machines are the most commonly used machine learning algorithms for COVID-19 detection. In deep learning, we saw that convolutional neural networks were extensively used for detection. Similarly, transfer learning models like VGG, ResNet, and DenseNet are also being used for detecting COVID-19. A major research gap that we identified was that the data sets used by most researchers were extremely small and needed a lot of augmentation. It was also observed that many researchers combined different data sets together to do the research. As stated earlier, RT-PCR requires a lot of time for getting test results. Hence, radio imaging is used to detect the output. Hence, we use radio imaging to get faster outputs.
This paper aims to use chest CT scans for detecting COVID-19 using deep learning methods like convolutional neural networks and VGG16. This is our architectural diagram. For this study, we used two data sets. The first one, which was used for training and testing our models, which is COVID X CT2, consisting of 1,94,922 images belonging to three classes: normal, pneumonia, and COVID-19. The next data set was SARS-CoV-2 CT scan dataset, which was used for validating the generalizability of our models, consisting of 152 COVID-19 images. We gave these images as inputs to a 5-layer convolutional neural network named as COV-ConNet and VGG16. We used VGG16 because it had been used earlier by many researchers, as we had identified in our literature review, and it had given very good results. Both these models were evaluated on accuracy, loss, precision, recall, F1 score, sensitivity, specificity, and RCAU scores. On the COVID CT2 dataset, both models performed extremely well. The table towards the left is for that dataset, and there was a very minute difference seen in the terms of accuracy for both the models. On the next data set, which was used for the testing of generalizability, which was the SARS-CoV-2 CT scan dataset, whose table we can see on the right, we see that our model COV-ConNet outperforms VG16. This in terms of accuracy, recall, F1 score, sensitivity, and specificity. We also compared our model with a paper by Gunraj ETL, who had used the dataset COVID-X CT2 for their research, and we saw that our models outperformed their COVID-Net CT model, which was giving them 98.10% accuracy. So sorry, there's a disruption in the table headings. Here, the heading should be accuracy, and this is sensitivity of each of the classes. Moving towards the conclusion. To conclude, I would like to say that due to the time constraints of RT-PCR and low accuracy rates of RAT, which is rapid antigen test, other alternatives were searched for, and radio imaging provided a good option. CT scans were used for COVID-19 detection in this paper. We used custom CNN model COV-ConNet and VG16. We used another data set, which was SARS-CoV-2 CT scan dataset, for testing the generalizability of our model. It was hence observed that COV-ConNet is a more generalized model than VG16. In the future work, we aim to increase the generalizability of our model, COV-ConNet. We also aim to use an ensemble of deep learning and machine learning models, and also use UNet and other such localization and segmentation algorithms for identifying the infected region in the CT scan. These are our references. And thank you, and open for questions.
Okay. Any query from the session chair?
Yes, I have two questions.
Yes, sir.
Swapnil. What is your model actually? Why are you not showing us the model which you have designed? I mean, you have just written COV-Connect, right? What do you mean by that? And what are the different layers you have used? How many layers? What's the
Yes,
memory?
sir. So as I said, that it is a 5-layer model, which consists of a convolutional layer, 5 convolutional layers, and after every convolutional layer, there's a pooling layer.
Yes.
And then there's the flattened layer, followed by a fully connected layer or dense layer, and then a dropout layer, and then the finally output layer.
So you should have actually put that slide, right? It's always better to check.
Yes,
Because,
yes,
and you have written here, the flow diagram here shows that you have used both the architecture, but the way you are representing the results is different, right? You have used two different architectures separately.
Sir. Yes, sir.
But you have written the two architectures is one after another, right? That's what is the first confusion. So what do you think that why BGG16 is not working and your model is working? You have
Sir,
shown us
we-
some results, right? Where also BGG in
Yes, sir.
16 is not working well, right?
Yes,
It's
sir.
not generalized at all, as you said.
Yes,
So
sir.
then, why? What do you think that why is your model working so well than BGG 16?
So our model was trained from the from scratch, so it wasn't trained on any other dataset earlier. But as we know, VG16 is trained on the
Are you not?
dataset earlier.
Have you
So,
not? Have you not fine-tuned it? The
so
VG16?
VG16, yes,
Yes.
sir, I had fine-tuned it. I trained on the model again. The previous grades were trained again, and after that, I had tested the results.
But in the literature, you have shown that most of the methods have used ResNet and DenseNet. Where is the result? Because the common, right? Common, I mean, method
sir.
people are choosing in this research. You have shown us, right? The ResNet
sir.
and DenseNet are the two methods that has been extensively used in this particular domain of research. So where is the result of DenseNet and where is the result of ResNet?
No, I did not add it because the data set that was used by other researchers was not similar to mine. So I haven't added in the PPT.
But ResNet is a popular method. It's available, right?
Yes, it is.
ResNet, like VGG, you could have implemented ResNet and DenseNet as it has been popularly used.
So actually, because the size of the data set was huge, so there was a constraint of the memory, and the compiler used to always give me resource allocation errors. So that is why we had to
So my
construct.
question here is very
Restricted.
simple. So what was your goal for designing your architecture? Because there are so many important and popular architectures, very successful architectures already available in the literature that has been extensively used in this field of research. So why have you decided to design your own architecture? And you have also written in one point also here, if you look at the fourth point, there is not a huge data set for COVID-19 radiography. So what do you mean by huge here? You are also considering the images in terms of lakhs, right?
Yes, sir. So the papers that we went through had the data set sizes were quite small. It was around 3,000 images or 4,000 images at max. But the data set that we got, which is the COVID X2 data set, which is available on GitHub as well as Kaggle. So that data set has around 1,94,000 images.
So what was your intention then for developing your architecture?
So since we got a huge data set, so we wanted to find develop something that could be generalized as we tested ahead also for generalizability, and so that it could be deployed for detection.
Okay, so for that we need to first compare with other methods as well, right?
Yes, sir. Yes,
you
sir.
can say our method is better. Only you have
Yes, sir. So this is just a
19.
preliminary phase of the research. So
VGG 19 is a very costly architecture.
yes, sir.
In a way, what I can say is VGG 19 contains more than 135 millions of the parameters.
Yes, sir.
Right? So
Yes,
maybe
sir.
the number of images or because of the overfitting issues, it is giving less results than your method, right? But you
Yes,
can
sir.
also use some lightweight models like mobile net architectures, right? Efficient or supple net architectures. And you can also verify your model, right? That's
Yes,
what.
sir. Yes, sir.
Okay, that's all from my side.
Thank you, sir.
Yes, Swapnil, I have a question.
Yes,
So
sir.
actually this COVID-19 detection is a very much explored area. Okay, many
Yes, sir.
methods are there. And as I think all model are already applied. And you are saying that your simple sequential model is better than the VGG. It is very difficult to understand.
Yes, sir.
If you tune your VGG model, obviously it perform better.
Yes, it could
And
perform
your-
better. Like the way I did
your
it,
model is
it
performing
wasn't.
better. Because it is very much explored area. You can download many papers, many methods. All type of methods is already applied.
Yes, sir.
I think it is very difficult to understand what you are presenting here. Okay, fine. Okay, from my side.
Okay, no questions from my side.
Okay, ma'am. Okay, Swapnil, thank you for your
Thank you, sir.
presentation. Yeah. Now please unshare your screen. Now I invite our fifth presenter, paper ID 421 Mr. Aditya, are you
Yes,
there?
sir.
Yes.
Yes, sir. Is my voice clear?
Yes, clear.
Okay.
Share your screen and start with presentation.
Sir, is my screen good, visible?
Yes, visible.
Yes. So my name is Aditya Paliwal and I am from IIIT Bhopal. Paper ID 421, detection of COVID-19 affected persons using convolutional neural network from X-ray images. So this will be a table of content. First, the background, literature survey, problem description, methodology, results and discussion, conclusion, and then the references. So COVID-19, which was first detected in China, was declared a pandemic during the March and April 2020. The main concern of COVID-19 was the detection of the disease, which would spread at a very high rate. In order to decrease the transmission rate, we need to detect the disease at a very earlier stage. Thus, it required a very high efficiency test kit. While the test kit was effective, it had a drawback of high cost and it took time to produce the results. Thus, many other methods were introduced. One such method was CT scans, which were used to detect COVID-19. Another technique, which was a LAMP technique, will also generated results, but it had a very less accuracy. Protein tests were also done, but it only checked for the antibodies, which were also found in the people who earlier had COVID-19. Also, the restraints with RT-PCR, which were costly and limited to only developed countries, which were difficult in the developing countries, which had only fewer kits. Sensitivity of the rapid antigen test cannot alone be considered for initial screening. So this was the reason why X-rays were introduced as a method to detect COVID-19. So this is a literature survey where we have presented it as a table of the 4 literatures which we have read. So Sarkar used a transfer learning model on the DenseNet 121 network to classify COVID affected and achieved an accuracy of 85.35%. Another Professor Xu used a CNN based model which was based on ResNet 18 and came out with an accuracy of 86%. Wang and Wong used transfer model technique on VGG19, MobileNet V2, exception, inception, and ResNet V2 to come out with an accuracy of 92%. Abbas also used a D-Track ResNet CNN and achieved an accuracy of 95.12. Professor Pachori also, along with their group members, developed various machine and deep learning based methods for the detection of COVID-19. So the problem which we faced was that RT-PCR cannot be the only way to detect COVID-19 as it has production constraints. So we used X-rays. So in our proposed model, we tried to increase the accuracy of the model of the X-ray models which were earlier produced. So we used a data set we downloaded the data set from Kaggle, which had 1726 images for training data set and 433 images for testing data set. These were the images which you can see where A is the healthy person's X-rays and B is the COVID affected person's X-ray. So the first thing that we did was pre-processing. So we converted all the images to a 224 into 224 resolution and then standardized the elements by dividing each element with 255. Feature extraction was done. Then the construction of CNN model. So there were input model, convolutional layer. We have the pooling layer, and then we have the dense layer. So this is the model you can see which we have proposed. Then we had the evaluation of performance, which were based on four things: accuracy, precision, recall, and F1 score. So after this, in this paper, COVID-19 affected persons were detected using convolutional neural network, and total we had 2,159 images, out of which 1726 were for use for training and 433 were used for testing. We trained this model for 5, 10, 15, and 20 epochs as shown in table 4. So this is the confusion matrix along with accuracy, precision, recall, and F1 score for 5, 10, 15, and 20 epochs. This is the way for each epoch how much the model accuracy was given by our model. This is the summary of all the developments of accuracy and precision. The obtained accuracy, precision, recall, F1 score, and support using 20 epochs were 96%, 96%, 94%, and 95% respectively. We had more than 1700 images, and the comparison with the earlier literatures is given here, where we can see that our proposed model worked with higher accuracy than them. This is the graph which shows model accuracy comparison. So in the end, in the conclusion, we can say that the proposed model gives an accuracy of 96% along with precision, recall, and F1 score of 96, 95, and 96% respectively. This could have been better if there would have been a bigger data set, and data imbalance could have been handled better. These are the differences, and thank you.
Yeah, any query from the session chair?
Yeah. So I have two questions.
Okay.
You said you have applied feature extraction methods. What is the necessity of applying feature extraction methods here?
Sir, CNN itself applies the feature extraction method
No, but
using
you have written something. Can you go back to that slide where you have written? Yes, yes. The entropy, geometrical, what are those?
Sir, we actually used entropy only, so to see whether what type of features could go well in the earlier papers.
I mean, you are not using CNN, the features that are.
No, sir. We are in the end. Then we use only CNN features.
Okay, but in methodology, you have written feature extractions, right? Bit confusing.
Yes, sir. Sorry, sir.
Okay, so this should not be there, right?
Yes, yes, sir.
Okay, so can you go to table number 6?
Table number 6. Yes, sir.
Yes. So you have shown that your model is achieving higher results, right?
Yes,
but
sir.
it is very marginal compared to the reference number 13, right?
Yes,
but
sir.
Is this comparison is a valid one? I mean, all of these methods have been validated on the same or under same experimental setting. Have you checked it?
Not on the same data set, but they use different techniques, sir. But they were all on the X-rays.
How can we compare? They've used a data set having different size, different
Yes, sir.
experimental setup. And how can
Yes,
we
sir.
directly compare these methods with your method? And how can we say that your method performance is better than them? Although they all have validated on different data sets having different size.
Yes, sir.
Right?
Yeah, right, sir.
Okay.
But they all were on the X-rays, so we tried to compare them based on the accuracy.
X-ray is fine, but the data set, the experimental setup is not same, right?
Yes, sir. That
So
is
maybe the
not
number
okay.
of samples are very less. Maybe some of them are multi-class, or if
Yes,
you are
sir.
considering a binary class, maybe most of them are. We do not know, right?
Yes, sir.
Only
Sir,
you have simply, taken the results directly from their paper.
yes, sir.
But as it is actually not valid. Just look into it.
Okay, sir.
Okay then. That's all from my side.
Okay, no question from my side, but actually, as sir told, that is correct. You can't compare the different data set with your problem. Okay, you need to take the same parameter. After that, you can compare.
Okay, sir. Noted, sir.
Okay, from my side. Yes.
Okay, no questions from my side too.
Okay, ma'am. Thank you, Adit, for your presentation. So last presenter, paper ID 329.
Yes, sir.
Yes. Suryakant Singh. Yeah.
Yes, sir.
Yeah.
I'm extremely sorry I not present in my session because I had some minor
Okay, no
accidents.
problem.
Thank you for reconsidering me.
So now you
First
can
I have-
share your presentation and
Okay.
start. Yes.
My screen is visible.
Yes, visible.
Okay. Good evening, one and all. I am Suryakant Singh, PhD research scholar in IIT BHU. I am doing PhD under guidance of Professor Rajesh Srivastava. My paper is CCL NET, Complete Comprehensive Learning and Modality Preserving Based RGBD Complex Salient Object Detection. The agenda of today's presentation is, first I will introduce the problem statement and then give the summary of research gap and current motivation to propose this model. And then after I will introduce some structural weakness of the existing models, and then I will discuss the contribution of our proposed model. Then after I will discuss the methodology, working of methodology and different component of proposed model. Then after I will show the result analysis and experiment. Finally, I conclude and discuss some future scopes to improve this models. So the salient object detection is derived from the cognitive domains. This problem is initially subjective. It is derived from the visual saliency. Visual saliency means identify the most prominent thing in an image. There are two stream in visual saliency. First is eye fixation predictions, and second was salient object detections. In eye fixation predictions is defined as to localize the prominent object in image, while salient object detections is to localize, predict, and detect the complete salient object in an image. So currently salient object detection is prevailing problems in challenging and complex image where we have to develop the computational algorithm to correctly detect, predict, and localize the salient object. Salient object is most prominent object of an image. So the application of salient object detection is in object segmentation, adaptive, object recognition, object descriptions, localization, image captioning, video captioning, content-based image editing, and many other visual and computer vision related applications. There are mainly 4 computational models till now are used to develop the algorithm. One is a statistical model, probabilistic model, machine learning based model, deep learning based models. Our proposed model is based on the deep learning based approach. So the visual salient object here, I demonstrate visually. In these models, we use RGB image, depth image as an input. Third image is the ground truth, real ground truth, actual output of this input image. And fourth image is our output of our proposed models. So I try to demonstrate that the input image have very complex and clutter backgrounds. Complex and clutter backgrounds means the object, some region of the salient object is also similar characteristics in the background regions. So in that type of scenario, only RGB based image is not sufficient to exactly predict the salient object, which have retained their outer structure of the border structure, edge structures, and inner structure of the salient objects. So both two images are very complex. In this complex image, our proposed model generate the salient object which preserve the object borders. Now, in current contemporary methods, most of the prevailing models only focus on the cross complementary fusions. Cross complementary fusion means the features from the RGB and depth images are used to fuse and predict the salient object. But I try to use cross-complementary, non-complementary, and intra-complementary base feature to fuse and predict the salient objects. So these existing limitations of contemporary model are used as a motivation factor to propose these models. There are two main structural weaknesses of the existing models in current SOTA, state of art seminar. So, state of art methods. So, the first problem, how to develop the strategy to explore complementary features, as well as preserve the non-complementary features. Non-complementary features means the feature which is totally depend on the modality, like we cannot fuse the depth and RGB based features. And other is how we preserve, how we develop the strategy to preserve the deep localized characteristics as well as silo based features, so that exact salient object will come out, pop out. So these three contribution I propose 3 stream network models, in which 2 stream is used to encode the RGB and depth feature. This is the RGB based encoder. This is the depth based encoder. This encoder is based on the VGG16 network model. This is the backbone network. And these 3 stream decoder, one is the RGB base and depth base, both are focus on the non-complementary base fusions. And third stream, fuse stream, is based on the cross-complementary and intra-complementary fusion. Cross-complementary fusion means the fusing the RGB and depth features. Intra-complementary feature means deep features. This CMF6 features guide to fuse this cross-complementary features. So I use intra, cross, and non-complementary based fusion to generate 3 stream-wise saliency. These 3 stream-wise saliency finally fuse based on the proposed qualified saliency models. And finally, this is the output of the salient object detections. So CCLNet, complete comprehensive learning based, mainly 3 component: modality dependent non-complementary fusion, cross-complementary fusion, and intra-complementary fusion. This is the mathematical definition of non-complementary fusions, where CI denote the layer-wise convolutions layer, feature of convolution layer, and this is the upsampling operations. Sigma is the denote the upsampling, and Rao described the channel-wise concatenation operations. So this non-complementary based fusion, where this side output of each convolution layer and previous optimized feature of the deep feature are concatenate, and after concatenations we perform the mathematical element-wise addition and element-wise summation operations to fuse this feature to produce the salient. This is the cross-complementary based CMF modality, cross-complementary based modality fusion. In cross-complementary based modality fusion, this is CMF module. CMF module collect the side output of each layer. So suppose here is 64 number of channels, here is 64, so 128 number of channels is here. Here is 256, here is also 256. So 512 number of channels. So this CMF module first combine the features of side output of each layers, and after concatenation, it compress the feature by using 64 number of convolution channels, convolution filters to generate the each stage equal number of channel. So each step have after compression total 64 number of channel. Then after we perform the dense decoding. After dense decoding, we perform the cross fusions. This is the mathematical formulation of cross fusion. RGB and depth-based element-wise multiplication. This is the element-wise addition. Final we perform the element-wise addition to generate the fusion of the cross-complementary. Now, intra-complementary aggregation model. This is the intra-complementary based fusion, where deep localized feature successive forwarded to the each stage of the each stage till the first layer. So this is the basically inception module. In basic inception module, the last layer input and output have a different channel. But in our application, we modify the inception module so that input or output have an equal channel, and that should be 64 number of channel. So each stage number of feature during the aggregation module is 64. So we perform the fusion operations. This is the optimization technique where we use. There are two steps to optimize. This is the deep localized features. After fusion, we downsample the ground truth image into 14x14. And this downsample image is optimized by using cross entropy loss functions. And this optimized downsample image had characteristic to localize the salient object. So it exactly localized the salient object in an image. So this optimized localized feature guide the cross complementary based fusions. So this is the balancing parameter. Alpha is equal to 0.5, and this is the cross entropy of each stream. This is the mathematical formulation. Now I going to discuss the result analysis and experiment. I rigorously experiment these models on various parameters, and all the parameter is recent. So I use 4 data.
Surya sir, sorry for interrupt. Yeah, please conclude this. Actually, there is a limited time for the 10 minutes only for presentation. Okay. So please continue. Okay. Yeah.
So I use 4 data sets and use standard training and testing patterns so that we fair compare all the existing models. And recently used 4 parameter: S measure, F measure, mean absolute error, and E measure. This is the mathematical formula of parameters. This is the visual demonstration of all the existing models as well as our proposed model. Our proposed model generate the salient object which is similar to the ground truth image. GLDCF D3 net S2 net P is the most preferred model, most available in the highly cited models. It is published in 2020. So I compare my result with these models, and there are 7 to 8 model is deep learning and 5 is traditional based model. So I compare my proposed model with total 13 state-of-art methods. This is the result of our proposed methods. This is the abelian analysis. I compare the demonstrate the stage-wise output of the proposed models and the fusion also. See the depth-based output. This is the color-based output. Cross fusion-based output. This is the fusion of depth and color, depth and fuse, and cross and fuse model. And finally, we use the finally this is the output of the salient object. This is the abelian study of quantitative evaluation of the each stage of the proposed model. Now I'm going to conclude the models. In these models, I will use intra-complementary feature, cross-complementary feature, non-complementary feature to preserve and learn our model to all possible number of feature in CNN space. And there are one scopes we can use, and I am also working on proposing this model. Attention-based models applied in the deep localized feature to enhance the deep localized feature so that the guided fusion is clearly distinguish the non-salient and salient region, so that non-salient will completely remove from the image and salient will completely highlight to, so that the object will completely pop out from the image. Thank you. And if any questions and query, please ask.
Any query from the session chair?
So what are the major challenges related to this problem?
So major challenges is, first major challenges is current existing model can easily segment, easily find the visual salient object in the image set where background is clearly distinguishable from the object. But the most of the model is fail in a complex and challenging images where the object and the backgrounds have similar characteristics. So this is the major challenge. A second major challenge is efficiency, because this salient object detection model is used in various computer-based applications. So this is as per my study, these are two major challenges currently to develop the model which take less amount of time. So my algorithm, this CCL net, generate the salient object in 120.124 milliseconds and 128 frame per second. So I will improve this model in the two perspective.
Okay, from my side.
Okay, so only one question that you said you are going to use attention-based models, right?
Yes.
So have you studied in attention-based models, or how did you come to know that yes, attention model will work for your model in the future?
Yes, I have studied, and even I have computed, applied this attention model in deep localized feature. There are channel-wise attention, spatial attention, non-local network-based attention model. That attention model is used to compute the long contextuals, contextual highlighting the features in different frames. Just like as a first image have 250, 224 cross 224 resolutions, and last is 14 cross 14. So there should be a mechanism which highlight the salient object in different resolutions. So that attention module is called non-local network. It is published in CVPR 2017 and NL network. So I have applied this NL block also. So I compare 5 to 6 attention model in deep localized feature.
What are those attention models you compared with?
Spatial attention model, a channel-wise attention model,
Okay.
non-localized network-based model, cascade attention-based model, and mutual attention-based model. All
Okay,
these
so
models is used in different applications like image captioning and image description, video descriptions. So I use those.
what you finally, I mean, conclude, or what you finally observed by applying all those attentions? But did you apply this facial attention and channel attention separately, or have you combined it?
I'm currently experimenting which combination generate the better result. I will finalize that attention models.
Okay, and what was your goal actually to use this attention model?
Basically, my goal is to the major challenge is the region of the salient object is similar to the region of the background. So
Okay.
use the depth feature. Depth feature have a characteristics to localize the salient, generate the object boundary of the objects. So this boundary of the object is used in the RGB image, RGB based feature, and apply this attention module over the RGB based feature where background or salient region have similar characteristics. So this attention module applied on the driven by the depth based feature distinguish the regions of the salient and non-salient and background regions. So attention module is used to distinguish the salient and non-salient regions.
Okay, that's all from my side.
Thank you, sir.
Okay, thank you.
Any
Ma'am, yes, ma'am. Question?
Yeah,
Yes.
just a small
Yes,
confusion
yes.
I'm having. So in one slide, you are using the term stream. So is it are you generating the data in real time fashion, or streaming means just referring the different format?
No, madam. I am not generating. This application is not for the real time application.
Okay, so stream is you are taking some like data formats separately.
Stream means modality based stream, just like as a
Okay.
depth stream, RGB based stream, and fuse based stream. Those three stream.
Okay, fine. So fine, no questions. Thank you.
Thank you, Surya sir, for your presentation. Yes, please unshare your
Thank you,
screen.
sir. But sir, I have one query. Sir, my paper is not present in their.
Yeah, no
mention
problem,
sheet.
no problem, no problem. We have adjusted the things and informed the particular for your particular query to the coordinators. So no problem at all. Yeah.
Okay, sir. Thank you. Thank you.
So it is requested to all session chairs and participants, please turn on your camera so we can take photograph. Please unshare your screen, Surya. Yes, just wait. Yes, thank you, sir and ma'am. Yes, now on behalf of NIT Raipur and organizing committee of the conference, I thank you all for sparing valuable time as well as providing valuable insights to the authors. It is kindly requested to session chair fill the evaluation sheet so that the best paper award can be decided and finalized. Yeah. Yeah, thank you, Deepak sir.
Yes, sure.
Yeah, Sanjeev sir, Sonali ma'am.
Okay,
Thank you so much.
Okay, shall I take leave now?
Yeah, ma'am, any comments or anything? Yeah.
No, it's all going fine. So
Yeah.
congratulations to the whole organizing committee for successful organization of MISP.
Yes, thank you, ma'am.
And all the best for remaining programs also.
Yes. Thank you, ma'am. Thank you so much.
Okay.
Thank
And
you.
all
See
the
you.
best for your research career. All the best for your PhD degree. In touch.
Yes, ma'am. Sure. Thank you, ma'am.
Bye.
Bye, ma'am. Thank you, Sanjeev sir, Deepak sir. Thank you.
Yeah. Thank you,
Thank you.
Venkat, for nice
Thank you.
organizing the session. Thank you.